Hello, and welcome everyone to the January LocalStack community meetup. I'm just so excited to get started with this year with this fresh community meetup, and I'm just so happy to welcome you all who have registered and who have been attending this meetup right now. So let's bring the slides onto the stage and welcome you all to this meetup. So this meetup is going to be about how you can streamline your development with LocalStack. And today we are going to be talking about two really awesome tools. We have got Quali with us, and we have got AWS Lambda Powertools, and we would be going over them and kind of introducing how you can use LocalStack with these tools and how you can get started with them. The overall focus is on the whole strategy of development and deployment and how LocalStack can ease this process with a multitude of integrations. And with that said, I guess let's go ahead and kind of take a look at the session and the agenda for the day. So for today, we will be getting started with an intro and welcome. That's what we are going through right now. And we have two really awesome sessions for the day. At first, we have David joining us, who is the Vice President of Research and Development at Quali. And he will be talking about how you can unlock ease of use for deployment across LocalStack and AWS. He will also be introducing Quali Torque, which is a self-serve tool that allows you to ease up your deployments across different cloud environments. And he will be showcasing how you can use LocalStack just for that particular purpose. Second up, we have got Brian joining us. For people who have been joining our community meetups for quite some time, you might already know Brian. He is the developer relations lead, and he will be talking about serverless best practices with AWS Lambda Powertools. He has also written a blog about this, and we will be sharing that link at the end of his session so that you can check it out later. And with those sessions, we will be concluding with a remark on our upcoming minor release that would be coming out this week. So with that said, let's go ahead and let's introduce the speakers for the day. So let's bring on the stage David and Brian. Hi, David. Hi, Brian. How's it going?
They're great.
Harsh.
Yeah.
Exciting.
It seems surreal. Like we have been organizing these meetups, and every time I'm on the later half of the day, it's like you folks are in the morning time, and like I'm in the most extreme evening time. And it's kind of great because it allows all of our audience to like kind of join from most of the major time zones across the world, which is simply great. But with that said, I guess let's do like a quick round of introduction. So David, you are pretty fresh like to these meetups. So maybe let's start with you.
Yeah. Harsh, thank you. Thank you for having me. I'm excited for sure. So I've been following, and I'm a big fan. So it's kind of an honor. So thank you. Just fun fact about myself right now, I'm doing a house moving to a new house, right, as we speak. So if I'm gonna do something like that and call someone or wave, sorry about that. Everything is a mess. Everything is up in the air. But I'm fully with you. And yeah, hope you enjoy it.
That's awesome. And when you mentioned about house moving, it reminds me of someone else. And maybe that someone else is on the call. So let's go ahead with Brian.
Yeah. This is a theme for this month's meetup, right?
Yeah.
Yeah, because I'm in the middle of a move. Well, middle is probably like overstating it. I'm just getting started packing. I'm moving. I currently live in Orlando, which is beautiful, but moving back to Boston, which city I lived in for 12 years and looking forward to going back to. But yeah, so I'm Brian. I lead developer relations at LocalStack. I've been on these meetups before, and hopefully today I get to show you some power tools, which is really cool, and hopefully you enjoy that.
That sounds awesome. So again, thanks all of you folks for joining this month's meetup. And with that said, I guess let's bring the slides back to the stage. So before starting with these sessions today, because I don't have to do a lot of heavy lifting over here, the only thing that I would implore is that if you have any questions coming out of these sessions, please do navigate to slider.com and enter this particular code where you can ask questions directly to the speakers. We will be adding these questions in, and we will be making sure that we cover majority of these questions at the end of each session. So that's your best way to connect with the speakers and get all of your doubts or all of your concerns clarified. If navigating to a link and entering a code seems too manual of a process for you, you can just scan this QR code and you can directly join our Slido session. whatever way works. But with that said, let's bring the first speaker for the day, David, onto the stage. He would be talking about Quali Torque. I described it as a self-serve platform, but maybe it is more than that. I guess I'll let David do all the talking and kind of tell us all the nuances of the platform. Over to you, David.
Yeah. Thanks, Harsh. Thanks. So yes, what I want to do is to walk you through what is Quali Torque and what the platform provides. Then I want to share you the tight integration that we have with LocalStack, as it kind of follows the same principles that we been preaching for quite some time about cost awareness, about how to be more efficient and streamlined and kind of reduce the bottleneck of waiting for your infrastructure. So that is essentially kind of aligned to everything that we're preaching, obviously doing it in a secure manner. So yeah, so what I want to talk to you about today is first the platform, giving a high level overview of what value it provides, how you can look at it and approach it, as it simplify the experience of deploying infrastructure on any cloud and any target in a very efficient and streamlined and safe way, right? So when you look at when you approach platform engineering, right, you would like to provide the ability to I would say open the end users to consume infrastructure in an efficient way, in a scalable way, right? So you need this engine that helps you deploy your infrastructure as code, to observe all the resources being created, later on to provide a governed self-service to end users, so nothing would be on the way and everything would be on the right guardrails, and later on the option to operate on top from day one to day end when you decommission that infrastructure. And when you look at Torque, you can maybe look at it in these 1, 2, 3 steps of kind of a journey that you might go through. The first one is curate. And by curate, we mean you have probably a bunch of IAC lying around, right? From Terraform to CloudFormation to Helm. That being said, those needs to be obviously consumed by end users. So the first step that you would like to do is kind of consume them and curate them into kind of an inventory of all the automation available in your organization, regardless of where they are right now. They can be cross repositories or a single one. And also, you would like to tap into those cloud vendors and to basically understand which resources are being provisioned and alive, and to make sure that they are consistent with the right tagging and also based on automation, right? And obviously Torque in that process gives you that visibility of whether that is consistent and codified or not. And if not, you can import them, codify them into that inventory piece that you will see in a minute. Right. So straight after doing the inventory, what you would like to do is to provide a very intuitive self-service to those automation pieces, right? So this is where a bunch of, I would say, tools that Torque has in place, from blueprint creation to a self-service catalog and to intuitive view of how do you consume infrastructure comes into play. We will see an example of that today as well. And lastly, once you have provisioned an environment that consists of cloud resources and maybe your application in it, how do you operate on top, right? From a self-service aspect for, I would say, end users, like how do you get everything that you need from IDs, links, some day-to operations and actions, to whereas you're an admin, and you would like to have continuous update for that code deployed to those targets, reconcile drifts, maintain governance, and I would say policies, make sure that they're unchecked. So these are all kind of incorporated into what we called an environment. So I use the word environment, and I would like to maybe kind of just give a rough kind of understanding of what you get when you have an environment. So ideally, you would like to be able to pass input and output between different components very easily. You would like to be able to fix errors quickly. You would like to have some insights about the resources being spun up. You would like to provide automation on top, and you would like also to have kind of cost visibility on top of those resources being provisioned, and much more, right? So all of that is kind of incorporated within what we call environment in Torque. That by itself provide full consistency between old cloud resources being provisioned. You can spin up short-lived or long-lived environment to be able to reproduce issues or dev environments. You can also provide a way to scale in a sense that now we will check out Quali with LocalStack, and without changing anything from IAC perspective and code perspective, you will be able to deploy to different targets, and by that just scaling your operation to multi-cloud from local to the cloud. So that's great. And to tie a bow on it, everything is as code, so it can be be part of your day-to-day and in your IDE. So no need of consoles or anything of that sort. That's great also for developers, of course. Okay. What I want you to see, and you can switch now to my view, thank you for that. So I thought it would be refreshing to see a perspective of how a user interface might look like a nice web UI, or I have my kind of LocalStack desktop, because I've been watching those webinars, and many times it's kind of showing the console, like get pods, list dockers, etc. Show just the IDE piece, and I do have those ready for you, but what I wanted to do is to give you kind of a glimpse on how it might be, if you were to log into a web portal and kind of consume it from there. And as I said, everything is kind of API based and as code, so it's very easy to maintain kind of GitOps principles in order to do that. So let's get started. So what I want you to see is how I'm starting with my local repository, and I have this is my local repo. By the way, fun fact, my name is David Ben Shabat, so I'm going by initial of DBS. So everyone knows me as DBS. Some don't know even that my name is David, but it is. And this is my kind of repo where I'm kind of doing a bunch of playground stuff. And I have a bunch of IAC here, like Terraforms. I don't even know. I don't keep track on it even. So I want you to now experience how Curate might look like for your flow and repos once you start with Torque. So you can go to settings. You can add a repository, and I'm gonna change that to ML repo just because this is what it is right now. I'm gonna choose the authentication method, and once you connect that repository, Torque should be able to scan and pick up those IAC. And as you can see, it discovered 50 new files. A few of them are Terraform, Ansible. Let's go check it out. So Curate starts with understanding where and what is your automation. So as you can see, I have here a few repos connected, many IAC files. Some of them are in use in different environments. Some of them are part of blueprints already that kind of create a more interesting orchestration of many components. And the thing is, usually what you would like to do is to provision those resources. So that can be done really easily by just launching an environment like so. You can always go ahead and click that. You will get a nice dialog. Everything is as code. So all the things that you now see is being represented as YAML as well, that can be reconciled as an environment. You have a nice input for end users if you want to. You want to definitely kind of end up with a very, very nice and comprehensive self-service. And right now we're looking at a self-service on let's say an infra portal type of view, right? So it contains like many kind of ad hoc resources that you can provision. What I think would be more interesting is once you want to connect more than one component into something more complete and meaningful and useful, instead of having to develop more and more code until you get into that sprawl that you're probably in right now, you can keep reusing the same component that you already have lying around, right? So for example, the KMS key that you have written that provides you with a certificate, and the S3 bucket that you have kind of lying around already and figured out, how do you connect those two together? So that can be done by creating blueprints. So let's check it out, like how a blueprint might be. So let's secure S3, for example, blueprint. So I have like an empty canvas here, and on the right, I have my existing building blocks that I can start adding. And if I have a problem or I don't find any building blocks that I already kind of own in terms of automation, I can always go and add few building blocks that Torque provides from the community. So you can go to AWS and kind of go pick whatever necessary missing piece that you need. You can always put that in your Git and own it. But this is kind of a nice way of listing all your building blocks. Now, as I mentioned, you can always start by dragging and dropping like the automation pieces, but you can also decide to go with the Copilot that Torque has that offers kind of a more kind of agentic experience of just use natural language, describe what you want, and Torque will create that for you. So when I go here and I would say, for example, create S3 bucket with KMS key. Oops. No. And the demo guys are with me, obviously. So what should be generated is two building blocks that looks something like that, which is nice. Okay, this is exactly what we wanted. What I wanted is to reuse the component that I already have to complete that, let's say, input and output between the two. I can later on, obviously, go into the settings and even kind of expose the different variables to my end users. So once I save it, like that, and I will maybe create a name, a different name, but Secure S3 is probably right for me right now. I'm going to publish it as a self-service catalog. So from that blueprint and orchestration, dependent on Terraforms, I will end up with a nice catalog item like that. When I launch it, and this is where it gets really interesting. So right now I'm relying on my code that deploys an AWS S3 bucket using Terraform. But, and I will give it a name, for example, LocalStack demo 1, and I give it a prefix like a DBS, and the region might be US East. And now I can choose an agent. And this is where the magic of the integration actually lies, because with zero effort and code changes, you can deploy it either on an AWS targets or locally on your environment. Agent can run and deploy and live on edge, on anywhere in the cloud, on a VM, it doesn't really matter. And once it's there, it can actually interact with the different component servers and provision whatever necessary. So I'm going to choose LocalStack, and I'm going to go and launch that environment. So as a developer, with few clicks, I'm now able to deploy a KMS key with an S3 bucket. Let's see how it goes. So we have the logs on the right, that should feel familiar as we're provisioning a Terraform, right? So for an operator, it's kind of important to see those familiar logs. We also see that as part of that environment, and I'm now an admin, I see many options, like, for example, updates, meaning I will track all the code changes from Git that I'm doing, and I can roll them safely. I can check for drift. I can use some automation, data automation on top. I can reconcile, if needed, any problems. But what I want you to see is, once I go here to my local stack and I'm connected right now to my server, right now I don't have any S3 buckets, but once that will be done, I will be able to check out, so the resources being created. Right now, I'm seeing that it's actually generating the right ARN based on local stack that I wanted, etc. So that's good. So we're just gonna wait for a few more seconds and kind of see the result, which gonna be an S3 bucket with my code in it, which is kind of a web game that I'm being deployed. And that's provide you with a secure connection to an S3 bucket. And now you fully emulated it locally using LocalStack. So let's check it out. Here is my DBS LocalStack demo. I can go inside. I can see that I've uploaded some web page, and I definitely want to download it right now. Let's download it, and let's check it out. Yep, this is my web game, and it's hosted on LocalStack. So that's pretty amazing. And the good part is, once I want to move that to production or to staging, the only thing that I need to do is to change that agent to be the target that I want, and that will take care of the rest. So with that said, I think that this kind of explained the end-to-end from how do you connect existing IACs, Terraforms, etc. How do you create blueprints very easily by just drag and dropping those components, connecting them together. You can use the Copilot kind of natural language to do that. And later on, how you can basically kind of deploy it and then operate on top. So I'm gonna leave room now for questions.
That sounds awesome. Thanks a lot, David, for introducing the Torque to us. And it looked pretty great because, like, I was kind of aware about this platform because of a previous demo that I did with your team. But again, like, just looking everything, like running in action, just seemed pretty surreal. So thanks again for introducing the platform to us and how LocalStack runs with this. The good part is we have plenty of questions for you, coming both from the Slido session and the YouTube live comments. So maybe let's put up the question that has been put up by Travis first. And this question is that I might have missed this in the beginning, but where does the IAC that this produces get persisted? Is it GitHub? Is it S3 or something else?
Yeah, so it basically needs a repository. So if you won't provide any, the code is persisted on the Torque's backend, right? So you can generate, and I can show it. Maybe, can I share a screen and maybe show it?
Yep, sounds good.
Yeah, so the code generated for this environment, we called it a blueprint, right? It's represented as a YAML, and right now it's stored in Torque. It's actually very simple. You're kind of stating the type of the IAC that you want to run, the store that it's being connected to, the path to that, and that is it, basically. Using this notation, liquid notation, we're actually stating that we want dynamic kind of resolving of agents. You can pass between the two different input outputs. Like, for example, if I want to pass the key ARN, I'm just using this path of KMS outputs, and I'm capturing this and passing that to the S3 bucket. So that is being stored in Git. So I can go and check out, like, if I have a blueprint that I already kind of have, I can go ahead and maybe kind of just save it here as a blueprint here, right? So that's pretty easy, and you can have descriptions for that, etc. Hope that answers your question, but that can be persisted in GitHub or any Git repository, GitLab, GitHub, Azure DevOps, doesn't matter.
That makes sense. I hope Travis's question is now answered. And moving on to the next one, I guess this is a question that more looks like a competitive question, but like some users, some of like one of the person like who has been asking this question, like they are using Terraform Cloud for quite some time. Is there anything better in Torque?
Okay. Uh, Obviously, I'm kind of biased, but I'm gonna take a shot at it. So absolutely yes. And I think that the key differentiators is first you can run different IACs that you have lying around. So if you have Ansible for day two, right, you want to keep use the right tool for the right purpose, right? So day two patching stuff or scaling concerns, etc., that can be covered using Ansible. You can definitely plug that and to streamline it using blueprints. Same goes with Helm and better yet, CloudFormation, right? You want to keep natively in AWS. Let's do that. So you can just leverage Torque to do that. And also keep reusing Terraform, obviously. The second thing, which I guess is important, is cost-wise. I think that once you kind of log in, you will understand that we're not charging by the amount of resources we're managing. You can put in an environment as many as you want, right? Which is important because you don't want to think about, okay, this is how I'm going to pay for it. So this is kind of a big differentiator. And lastly is about the self-service. And I would say that at the end of the day, you would like to scale and you have the specialty to work with Terraform, right? But you want to elevate it up to the business users, right? You want them to start consuming that without you in the middle or tickets or anything, right? So you would like a self-service that is fully governed with policies, which we haven't saw, but it's kind of baked into the platform. So just consumers like product testers, devs, etc., can actually access infrastructure and start working on top.
That sounds great. I guess that answers the question. We have another one, and this is something that even I was curious about. That are these blueprints or the building blocks created by the community? How exactly are they maintained? Because like I had a look that you created a blueprint out of your own, like the use case that you had. But is it also something that the rest of the community kind of contributes back to, similar to how we have got Terraform modules out there?
Yeah, yes. So as we discovered, many of I would say the use cases and infrastructure and patterns in organizations are actually unique. They have slight, deviations, right? They're not always the same. So we definitely have a large community of either blueprints or Terraforms or cloud formations, right, being generated that you can subsume easily and augment them to your needs. So yeah.
That sounds great. Um, I guess we can take this question as maybe the last one. And this is about like, can we also use this with CI pipelines, like local stack running in the background, maybe as an agent against which the IAC is deployed?
Oh, yes, of course. Torque comes with a comprehensive integrations to CI pipelines. Obviously, what we want is to maintain the life cycle and state of environments, right? And that needs to be plugged nicely into CI. So you would to build, test, pack, and then obviously deploy and kind of operate, run the test on top. So definitely we have integrations to all CI pipelines, and you can also use Docker or APIs to do that. That's comes in the product, definitely.
Sounds great. I guess we can take up all these questions. So thanks again, David, for introducing the platform to us and giving us such a nice demo. I guess it would be also be interesting to kind of further explore like different collaboration opportunities and how we can work together out to help out the community just manage their infrastructure better and also have a better way of defining and just keeping a hold of their cloud infrastructure around. So thanks again for being a part of this meetup. I guess we'll be in touch. And with that said, let's bring Brian to the stage, who will be talking about some serverless best practices. Hey, Brian.
Thanks, Harsh. So today I'm excited to talk to you about something that I've been messing with a lot, which is called AWS Lambda Powertools. And so let's just kind of jump into it. So what I'm going to cover today is basically what the heck are AWS Power Tools for Lambda, and then we're going to walk through a bunch of examples of different pieces of Power Tools. This will make a lot more sense once I cover like the what is Power Tools, but we're going to talk about logging, metrics, tracing, parameters, and item potency. So, every developer likes to think that they follow best practices, but I mean, the truth is we tend to take a lot of shortcuts. In many cases, that's because, well, it's not always clear what the best practices are. I'm sure that many of you have seen lots of debates about what, which are the best practices for any kind of development that you're doing. And even when there is a clear-cut like set of best practices, they can often be difficult to implement. Um, hold on. There we go. It's moving ahead. So that's what AWS Power Tools for Lambda helps you with. It basically is a way of codifying best practices that AWS has determined for building serverless architectures and giving you a way to integrate those into your Lambdas. So what AWS Power Tools is basically a set of libraries that encapsulate all of these best practices that you can integrate into your Lambdas. So they've basically determined a number of best practices for serverless architectures, created little sub libraries into those, and then you can add those into your Lambdas. Basically, they're very opinionated, first of all, and they're completely reusable. So it's easy to just kind of add those across your entire serverless architecture across the different Lambdas that you might have. So they're available for Python, for TypeScript, for Java, and for .NET. I will have to note here that you don't get the exact same set of libraries for each of these languages. Python is definitely the most comprehensive of the bunch. So it includes a ton of different libraries. Java would kind of be second. It's almost on parity with Python, I believe. TypeScript and .NET, unfortunately, have less libraries included in them, but they do include a number of the key ones as well. So these are the libraries that are included in Power Tools for Python. You see there's 16 of them right now. They cover a whole bunch of different types of things that you might need, from things from like adding streaming to feature flags to event handling to item potency and tracing and so on. All of these, again, are designed to be reusable, so you don't have to go and add the entire set of 16 into your Lambda. You basically choose the ones you need for that particular Lambda, and you can add those in individually. And they're designed to be really easy to use so that you can kind of configure them pretty simply. In some cases, even as we'll see, you can use middleware to kind of automatically do some of the work for you. So they've created middleware wrappers that will do that for you. And in most cases, even if there isn't, they're pretty simple to implement. And the documentation is actually quite good. So today, I can't obviously cover all 16. You all don't have enough time in your morning for me to do that. So I'm only going to cover these right now. And I am a full stack JavaScript developer. So I'm going to be showing you to the TypeScript versions of these. And again, TypeScript is probably one of the ones that has the least number of support along with .NET. So it doesn't have the full 16, but I'm going to show you the tracer, the logger, metrics, parameters, and item potency. So what we're going to talk about with each of these is, first of all, what the heck does it do? And then I'll tell you which languages are that Power Tools supports it in. And then finally, and then we're going to talk about, all of my demos are going to run in LocalStack. Obviously, I work for LocalStack, so I love LocalStack, and we're going to talk about kind of some of the limitations of running these in LocalStack. I'm going to be upfront right now and say the great news is all of these work in LocalStack. So there's not one that doesn't work in LocalStack. There are just some like kind of caveats you might need to know about how they run in LocalStack, so you're aware of like how you might actually test that everything is implemented properly. And then I'm going to show you some code. Obviously, like I said, this is going to be in TypeScript. I will try to run a couple of these examples. I'm not going to run every one because it gets kind of redundant. It's just basically, oh, look, it ran. But I'm going to show you kind of the key ones that I think illustrate how they work, how easy they are to implement, and also how you can use them in LocalStack. So the first one I'm going to cover is logger. So one thing to note, for reasons that I don't quite understand, in some libraries, like some languages, they call it logger, and in some of the others, they call it logging. Obviously, it's the same thing, but you might be wondering to yourself, like, okay, why do I need a library to implement logging? This is pretty simple. I could do that without a library. The thing is, though, is that CloudWatch supports something called structured JSON. And structured JSON allows you to do things like add a kind of log level to your logs. You can even add data as JSON, and that data can then be used for searching your logs or for visualizing different aspects of your logs and things like that. And so what Logger does is basically make it super easy for you to add this structured JSON and log levels and things like that. So it's very opinionated about how you do that, and it just makes it easy for you to add those into your Lambdas. It also, as we'll see, even supports some basic logging of some of the kind of context of your Lambda, so you can automatically log things like that. It's supported on all of the different languages that Powertools supports. And that's going to be true, honestly, for all of the ones I talk about today. I'll say ahead of time, because basically, if it's supported in TypeScript, it's pretty much supported in all of them. That doesn't go the same, say, for Python. Some of the things in Python, obviously, are not in TypeScript. The limitations on LocalStack are basically like, okay, so we do have the ability to run this. It's going to run perfectly, but the CloudWatch logs on LocalStack on the LocalStack web app don't support like parsing that structured JSON, so you're not going to get the same visualizations that you might get within the AWS console. But I'm going to show that to you so you can get a better sense of how that works. I'm going to jump out of here. I'm going to jump into my VS Code. First thing I'm going to do is just to note, you'll see me using the make just to run these. Basically, all the make file is doing is bootstrapping and then deploying the different examples here. So I'm going to go ahead and make, and we're going to deploy the logger. So this is going to deploy it to my local stack that's running right now. So again, you can see I'm just using CDK local bootstrap, CDK local deploy. If you're not familiar with CDK local, it's basically local stack's lightweight wrapper around CDK so that it deploys to the proper location, which is my local version. So I'm going to go ahead and I'm going to go to the logger Lambda so we can kind of look at the code and you can see how easy it is to implement. Basically, all I did here was I imported the correct library, which is just all I want is the logger. Again, I mentioned they have middleware wrappers. In TypeScript, they use something called MIDI. This is entirely optional. You don't have to use their middleware, but I did use their middleware, and we'll get into a little bit of why I did that. So in this case, you can see I instantiated the logger here. And then I'm going to set the log level. I've actually used the default log level, but it basically supports debug, info, warn, error, critical, and silent types of log levels. So I'm just using the default info log level here, just to kind of illustrate how you might set that log level. I am also going ahead and actually manually passing in a log message, which is just, again, simple example message. But in this case, I'm passing in data that's data from within my Lambda. I'm going to pass that in as JSON, and I would be able to then, within CloudWatch, I'd be able to see that data, search that data, and do different things with that data. I'm also using the MIDI middleware, as I mentioned. And what the MIDI middleware in this particular case is doing is actually going to inject details about the Lambda context automatically into the log. So even if I didn't actually manually include these this logging message, there would be some information automatically logged about how my Lambda was performing and passed into my log messages. So let's go ahead. I've actually deployed that to LocalStack. So I'm going to go ahead and sorry about that real quick. I'm getting rid of that. So I'm going to go, you can now see if I go to my overview here, for those of you not familiar, this is the LocalStack web app. You can now see like I've got Lambda function running here. I'm going to go ahead and go into my resource browser. I'm going to go ahead and open this logging function. I'm going to invoke it. So I'm going to I don't need to pass any payload. Oh, of course. Of course, we get an error. Demo gods, please give me make this work. Okay, I'm gonna try refreshing this. Sometimes what happens is I have an old version that because I was testing it this morning. We're gonna try it one more time. God, worked perfectly this morning. So let's go ahead and invoke it. Did not. Okay. Well, I will move on. Sorry about that. Unknown error occurred. Great. This worked an hour ago. All right, so we'll move on. Basically, what you would see if this had properly invoked is that I would then be able to go into my CloudWatch logs, and I would be able to go into this logger function and see the logs where uh, where you would see the message that I passed in into the logs here. You would see that structured JSON that I passed in. You would see here in my log messages. Again, it wouldn't be visualized in the same way you'd see in AWS console, but you would be able to verify that it is actually passing in these things properly as well. So let me go ahead and restart LocalStack so I can go ahead and show you different demos, and I'll jump back into the slides. Hopefully for the future ones, oh, the demo gods will be with me. All right, going back, I accidentally hit the wrong button, throwing me off. Okay. So the next one I want to talk about is metrics. So as we discussed in the prior talk about logging, that CloudWatch supports this embedded. You can embed JSON into your log files. They also support something AWS calls the embedded metric format. Basically, what embedded metric format allows you to do is to include a bunch of data in your metrics in your log messages, and those metrics can then be used to visualize different aspects of how your application is performing, and you can even add alarms based on those metrics so this enables like basically real-time instant detection using just your log messages. And what the metrics library in this case allows you to do is simplifies writing these metrics into your logs in the proper format, while also even allowing you to do things like adding validation to those logs to ensure that basically the metrics you're passing are valid for that particular metric that you're trying to track. So it is again available on all the different languages that are supported by Powertools. And the limitations on LocalStack for now is basically there. In similar to tracing, LocalStack doesn't support parsing the embedded metrics format yet. So you're not going to be able to visualize these in the same way or add like the alarms and different things like that. You will be able to actually doing similar to what I was trying to show earlier, where you will be able to go into your logs and see that the metrics are being written out in the proper format via your CloudWatch logs, but you won't be able to visualize them in the same manner you would using CloudWatch on the AWS console. So I'm just, in this case, I'm not actually going to run this, which is probably a good idea, seeing as things did not work properly for me the first time, but I'm going to go ahead and show you so you can kind of get a sense of what this looks like. Again, I'm just, in this case, importing the metrics library. I am going to import the middleware here. So the middleware in this, what happens with metrics is that they're added asynchronously, and basically they're not written basically as you each time you add a metric here. As an example, it's going to dump those all in batches. What the middleware in this case will do is automatically kind of process those logs so that you don't have to worry about having to manually send those logs for processing. So you can add your metrics, and the middleware will take care of passing those metrics into properly into your logs. So in this case, I'm just going ahead and importing the middleware as well, which is that MIDI middleware again, to wrap my handler here. I am instantiating the service. You give it a namespace, so that's the way the metrics work, is they have a namespace and service name. I just kind of gave it silly namespace and service name for the case of a demo. And then we're going to add a metric. In this case, the metric can be whatever you want, and I can even add like a validation, which is kind of what I'm doing here with this metric count. metric unit.count. I'm giving my metric a name. I'm adding some validation, and I'm adding a value to that metric. And that metric will then be written out into the logs. I'll be able to visualize that, even add alarms on that and things like that. Obviously, successful run is not necessarily a particularly useful metric, but you can imagine like a lot of different metrics that you might want to add in here that you would then want to be able to visualize or be able to add some alarms on in case your application runs into any issues. And so, as you can see, this makes it super easy to implement this. It's just instantiating the library and adding a metric at any point you want. All right. Jumping back, and I'm going to hit the right button this time. There we go. Next, I'd love to talk about Tracer. Now, Tracer, to me, I mean, immediately I think of the Overwatch character, but unfortunately today I'm not talking about the Overwatch character. I am talking about the Tracer library within AWS Powertools for Lambda. And what the Tracer library is a way of working with AWS X-Ray. If you have heard of AWS X-Ray before, it allows you to do end-to-end tracing of requests within your AWS application. So before I kind of get into dig into more of the details of this, I kind of want to make sure you know what that does and why you would care. So because there's a lot of terminology involved here. So trace is within the concept of X-ray. A trace is the full end-to-end request. Within that trace, there are things called segments, and those segments might represent different aspects of your application. Like, as for example, you might have a segment that's the front end of the application, another that's the API. Depending on how the scope of your application, you might have different segments. And even within those segments, there are things called subsegments, which can represent kind of pieces of code that you want to be able to track independently. Once you've basically instrumented your entire serverless application using the metrics tool base. You can visualize everything within X-Ray, which is kind of what you're seeing here on the screenshot. So you can see it's visualizing all of the different aspects of the application, as well as tracking different metrics around the different segments and so on and so forth. So then that should give you a sense of what the Tracer library within Powertools does. It's basically going to wrap that AWS X-Ray SDK with some opinionated ways of implementing it, and then automatically add trace data for you to instrument all your Lambdas. So it just makes it much simpler. If you want to add this X-ray tracing into your Lambdas, you can do that using the Tracer library. So I'm going to jump right here in to show you how that's implemented. Again, I'm not going to run this one again, but I'm going to show it to you. Not the CDK Tracer Lambda. So you can see in this case, I'm importing the Powertools. I am actually going to, in this particular record, we are actually implementing some DynamoDB table writing. So I've got different aspects of the application that I am annotating. So as an example here, we've got the subsegment that I'm adding an annotation. This annotation is actually going to have details that I want to be able to track, like the new ID that was created by the inserting that record into DynamoDB. I'm going to close that subsegment, and you can see also here in this case I need to actually wrap the tracer around this DynamoDB client, so that it can capture different aspects of that DynamoDB interaction automatically. So there's different wrappers like this for different aspects of your AWS application that you might be interacting with. In this case, like I said, it's just DynamoDB, so I'm doing that. And that's basically it. I mean, it's relatively easy. I've now added metrics that once I'm running this Lambda, those metrics can be visualized. You'll see the segments and subsegments that were created in there, and be able to track how this Lambda is running and visualize that within X-Ray. Again, one of the limitations, which I didn't cover yet about this within LocalStack, is that while X-Ray is supported in the paid tier of LocalStack, it's not the full set of APIs. It's a limited set of APIs. And then the other big thing is there is no X-Ray front end in the LocalStack web app. So you're not going to kind of get that full ability to visualize these things within LocalStack. But you will actually be able to use the AWS CLI to make calls out to X-Ray to verify that everything is functioning properly, so that you can be sure that your metrics are working properly before you fully deploy them to AWS. Okay, so in many cases, you're going to have lambdas that, I mean, pretty much in all cases, that need to access secrets or some kind of shared parameters that you'd use across your entire serverless architecture, all of your lambdas basically. And the parameters library within Powertools does make it really easy to retrieve parameters from either AWS Systems Manager, Parameter Store, Secrets Manager, AWS App Config, or DynamoDB. And I didn't mention here, but you can actually use your own parameter store if any one of those is not the one you want. You can configure your own parameter store. Some of the things it will do for you is actually make it, it'll do automatic JSON transformations. So if your parameter contains JSON data, those will be converted back and forth, for you automatically. It will cache the value for you, so to make retrieving that parameter on subsequent calls will be faster. All of that is kind of automatically built into the library for you. So that if you're wondering why I might use this parameters instead of using accessing each of these individually, that would be kind of one of the reasons why you might do this. It's supported on all the languages again, and there are no known limitations of using this on LocalStack. It'll work exactly as you would expect it to. But one thing I'll note is app config is only on the paid tier. So if you're using the open source version and you need app config for this, you'd have to upgrade to a paid version of LocalStack. But things like DynamoDB and stuff like that are going to work out of the box. So let's take a quick look at the code for that. I'm going to go here. We're going to go ahead and look at parameters Lambda. I'm actually going to, let's try this again. Let's see if this works. We're going to deploy parameters and see if we can get this working. All right, so as that's the point, I'm going to show you, it is super, this is probably the easiest one of all the ones I'm going to show you today. This is definitely the easiest one to use. All I'm doing in this case is importing the parameters. In particular, I'm importing the one I want to use. I'm using SSM. So for this particular set of parameters, so I'm only importing the SSM library. Obviously, depending on which one, if you're DynamoDB, I do DynamoDB. And then I'm going to say just call get parameter. I give the name of the parameter as it's stored in SSM. And do I want to transform it? In this case, my data is stored as JSON, so I automatically want to transform it. And then all this Lambda is going to do is return that parameter as a string. So let's see. We're going to try this again. The demo gods are going to be with me this time. I could feel it. Like I said, I did run all of these things this morning. Everything ran perfectly. But for those of you who have done presentations, you're probably well aware of what can happen. It never seems to actually, same thing will work beforehand and then break after. There you go. Hey, this one worked. Yay. So again, very, very simple, but you can see I did invoke that Lambda, and this is the parameter that was stored as JSON being passed back from SSM. And I'm able to just kind of return that here. Obviously, in most cases, I wouldn't be returning that. I'd be utilizing that somewhere in my Lambda. But for the case of example, so you could see how this works, I did it this way. Okay. Before I get there, I'm going to make sure I restart LocalStack because I got one more example I want to go through with you. And that is idempotency. So if you're not familiar with the term idempotency, basically, it's a way of describing a function that, if called multiple times, is going to return the same result and actually won't, in this case, won't run the same. Okay. So to return the same result, but it's idempotent, meaning it's not going to affect, like, it's if you have a transaction, it's not going to run that transaction multiple times. Like as an example, if you have a bank transaction and let's say a deposit, and you have a Lambda that's going to handle your bank deposit transactions, if that Lambda happened to get called multiple times with the same context and inputs, you would want to ensure that it's not going to run multiple times and actually insert multiple deposits, because you want to make sure that that would be a very, very costly mistake. You'd end up giving somebody a lot of money that they didn't really have. And you could think of a lot of different examples of where you might want to ensure that if this function gets called multiple times, that with the same information, it's not going to run again. It's just going to return to you the proper results, but without actually inserting a new record, because it knows that that record was already inserted, right? So that's what this library handles for you, is essentially turning your functions, making your functions idempotent. As you can imagine, like that's not that easy for you to implement on your own, because you would have to store the context information for the Lambda that's being called in some kind of persistence layer, and then you'd have to verify that that Lambda you have the same data and context, and then make sure you can return the proper results in case that has already been run, so that you can return something valid, but you're without necessarily inserting a new record. So all of this is wrapped up in the idempotency library within Powertools. So you can convert your Lambda functions into idempotent operations that are safe to retry. And it supports DynamoDB as its persistent storage layer, so that it stores the event data in there, and that's what it uses to verify if this is the same call being retried. So it's, again, in all the languages that Powertools support. And there are no known limitations within LocalStack, so you can use this as is out of the box, even in the open source version. So I'm going to show you that. I'm going to actually go into the code. It makes it easy to run, easy to implement, but I'm going to go ahead and try and run it. Yeah, we're going to do this. We're going to deploy idempotency. Okay. And then while that's going, I'm going to look at the Lambda here. So in this case, we're importing the Powertools idempotency library. We also need to import the DynamoDB persistence layer. The rest of this is basically for interacting with DynamoDB. So what I'm doing here is I'm creating an imaginary subscription that we would, so if somebody's subscribing, we would not want them to subscribe many times. I'm passing some kind of data here to store in DynamoDB. You can see what I've done is instantiate the persistence store. So I'm telling it what the table name of the persistence store. So you will have a DynamoDB table that will be my subscription payments, but there is also a DynamoDB table that handles the persistence of the context within the call of this Lambda. And then I am wrapping my handler in this make idempotent function here. So that's what's going to handle ensuring that it gathers all the context, stores those contexts, and if necessary, will return the results of the prior try of that function, as opposed to reinserting the data. So that's all that's really necessary. Really, really easy for something that I think is kind of complex if you were to try and implement it yourself. So I am going to go ahead and since I deployed this, I'm going to give it a shot and see if we can run it. You can see I've got two DynamoDB tables. One is the payment table that handles those subscriptions, and then this is the idempotency table that's going to handle persisting the context for you. I'm going to go ahead and I'm going to run the Lambda. I've got some data, some fake data here that we're going to use to run this Lambda. So we're going to call this function, invoke it. I'm going to pass this. So I'm going to invoke that once. Hopefully this works. Yeah, okay, payment created. I'm going to do it again. Oh, even a third time. But now I'm going to do it I'm just going to change the data here, and we're going to go ahead and invoke it one more time. So now I'm going to go back here, and I want to go into DynamoDB. And I'm going to go into my payment table, and view the items, and you'll see that even though I invoked that new subscription one 3 times, I only have one record here. Even so, I only have one record, but it returned me the proper result from that function on the retries. So it didn't error out and it didn't create a new record. So that function is fully idempotent. But when I changed the data that was going into there, as you can see with subscription 2, we now have a separate subscription record written in. So again, super, super powerful. This is one I definitely recommend you check out because there's so many different times you might want to use that. So that's it for my demos and for the libraries I'm going to show you today. If you want to actually look at that code, it is available on GitHub. So it's in our LocalStack samples repository. Sorry, not repository, whatever. It's in the PowerScript TypeScript demos repository, or you can just click that QR code that's right there and you can go there. So I'll give you a second to click that if you're interested in actually pulling down those demos and running them yourself. Either they'll work obviously in LocalStack, which is where I showed them, but everything will also deploy to AWS exactly as is. No changes needed. So if you want the full article that goes kind of more into detail about all of these different things than I can go into in this particular presentation, I would check out the blog post that I wrote on the LocalStack blog, which is serverless best practices with Powertools. And you can go to that URL, or you can scan that QR code and read the full article and walk through the demos yourself. So that's it for me. I'm going to go ahead and exit out of here, and I'm going to take questions.
Awesome. Thanks, Brian, for introducing the Lambda Powertools. I guess we do have got a bunch of questions out here. So let me
Okay.
just put them on the screen right now. Yep. The first question is like, is there any alternative to Lambda log viewer in LocalStack rather than using CloudWatch?
That's a good question. I've only ever used CloudWatch for Lambda logs. I maybe Harsh. Is there an alternative?
Yeah, so I guess the best alternative is to just enable verbose logging when you are starting LocalStack. That will also like put the Lambda logs right over to the LocalStack logs itself. Or if you're like using Docker Desktop or any sort of container runtime, you can just go to the specific Lambda container and you can check out the logs over there. But I'm not so sure whether the logs that are being emitted by the PowerTools library will be present over there. But if that's coming out from a Lambda function, then it should be present over there. So I'm just going to take a best bet on this.
Yeah, I would imagine it is. I didn't dig into the logging. I didn't have my local stack set for verbose logging, but it should be there in the logs on there as well. Because it is a standard log. All it's doing is making sure it's formatted in the proper format for like the the JSON structured data and things like that. So, yeah.
Yeah, sounds good. I guess the next question is that does the additional instrumentation by PowerTools impact cold start times on AWS LocalStack? Is it something that you noticed out there?
So according to them, no, like particularly the one for metrics, because it's all asynchronous, they claim there is zero impact on cold start times either on AWS or LocalStack would be the same. I don't believe there's any real the impacts of the logging library and things like that are negligible if anything. So no. And that's according to their documentation. There's no real impact.
We have got another question about the idempotency. Like, isn't Redis or Elasticache a better fit for this? And is that supported in PowerTools or LocalStack?
It might be, but I don't believe they support it. I'm going to double check right now. That because I believe right now it is only in DynamoDB for whatever reason, at least in the TypeScript version that I was using. Info DynamoDB. Yeah, it does appear right now that the DynamoDB is the only persistence layer supported on the TypeScript one. It may be different on Python. Let me check
Makes
that.
sense.
Actually, yeah. Actually, yeah. So there you go. Remember, I told you that the the TypeScript one kind of lags behind Python. So Python, the Python version does support Redis, whereas the TypeScript version currently only supports DynamoDB.
That makes sense. And moving on to the last question for the day, maybe. X-Ray isn't fully emulated, tried out a year ago. So any plans to support that? So maybe I can take this question up. We do have plans of re-engineering our X-Ray provider, and this would be coming about before the 5.0 measure release that we'll be doing this year. So I would just say like keep a watch out, and we are definitely trying to improve as many emulators as we can, and X-Ray is just one of them. If you have got any specific feature requests or specific APIs that you would like to see the emulation for, the best thing that you can do is straight up go to our GitHub issue tracker and put an issue right over there. And our engineers can basically take a look over that and also use that to further plan how to add the emulation support for X-Ray. But with that said, I guess we are okay. So we have got another question that just came from Travis. Thanks, Travis, for putting so many questions for us. But let me just put them really, really quick and put them on the stage. So you can run an agent from Datadog, Splunk, etc. on your Docker image to export these logs to their service. I'm not sure if that's like really a question.
It's not a question. It's more of a comment.
Awesome.
Yeah, that's useful information, Travis. Thank you.
Yeah, awesome. So thanks again. And I guess now we can move to the concluding part of this session. So thanks again, everyone who joined us. We got a pretty healthy audience today, both on YouTube and on LinkedIn. So thanks again who have participated in both these sessions. The one thing that I would definitely like to highlight is that 4.1 is coming out this week. So if you have not checked it out, we released our 4.0 release, which happens to be a major release just last year. And we're also like putting 4.1 out, which has got some great support for a lot of different things and a lot of different initiatives that we have been working on. Just to speak broadly, we have shipped the support for GIS Sonata and variable expressions and step functions. We have also added a new provider for Kinesis Data Analytics version 2. We have also added like a lot of new enhancements in step functions, CloudFormation provider, S3 provider, and more of that. So keep a watch out on our socials, and definitely join our Slack community if you'd like to learn more about the release. And like I always say, it is always good to upgrade because we are constantly shipping out a lot of these new changes and new enhancements, bug fixes, and all of that to make sure that you have a pretty great and smooth experience working with AWS. So make sure that you upgrade, be on the latest version, and try out LocalStack today. And if you have got some feedback, definitely join our Slack community and let us know your thoughts. With that said, thanks everyone again who participated in this session, and I'll see you around in the next month's community meetup. Have a good day, folks.